You have your targets down? So we're just going to jump right into it and start working on some example problems. First we'll work with expressions, and then we'll jump into equations and actually find solutions using quadratic techniques. So remember that a quadratic is something of the form ax squared plus bx plus c. Why is it called quadratic? Because the degree is 2. So we're going to find things that do not have degree 2, and we're going to come up with clever ways to make them degree 2 so that we could like factor it or something behind it. It's like a fun puzzle. Okay, so let's jump right into the first one. For example 1, there are 4 parts. Our job is to take each one of these expressions and to try to write it in quadratic form. So if you look at A, is that in quadratic form? Does it have degree 2? No, this is a polynomial with degree what? 4. But we get clever. We get really tricksy. We come up with something called U substitution. It's called U substitution because there's a U in it. We use this a lot in calculus and pre-calculus also. We just do this clever little trick. If we first look at x to the 4th plus 13x squared plus 36, we look at that and we're like, well, that's hard. But then we say something. We say we're going to do a little substitution. And what I'm going to do is this little magical thing where I'm going to take u and make u equal x squared. Why did I do that? Because now, if I look at the expression again, this x to the 4th becomes u squared. What does this 13x squared become? 13u plus 36. And I say, why in the world did you do that? Because now this is something that looks like it's in quadratic form. And if this was an equation and it had an equal 0 at the end, I might be able to factor it and solve for u. Or I could use the quadratic formula and solve for u. Or I could complete the square, right? And once I do that, I can figure out what x squared is, and then I can figure out what x is. So that's how you write something in quadratic form. You have to use this u substitution. Yeah, let's look at b. How do you write b in quadratic form? Right now, this is degree 6. So how do we take this 16 x to the 6th and get it to be something squared? There's going to be an x cubed in there. What about the 16? What does it become? Well, whatever number you write in here, you need to square it, and it should end up with 16. So that number has to be 4. And then this minus 625 can just remain as such if you want. Or you can actually take the 625 and take the square root of it also. What would that be? 25? Yeah, you can make it u or x. This is still x cubed squared. What I did here is I just made u equal x cubed. So I could write this as 4u squared minus 25 squared. Or you can leave it as 4x cubed all squared. It really doesn't matter what it's an expression. It's going to matter more when it's an equation that we can actually solve. So I guess on C, if you're going to go with the u thing, what would you make u equal? This one is a trinomial, which kind of looks like the first one. Do you notice in the first one that I made my u, if there's a u substitution you can do, I make my u equal to the second part, the second term. So what should I make it equal here? Well, it would need to equal x squared, right? Well, if I do that, is there a way to take this 12x to the 8th and make it something squared? Not really, because this would be like u to the 4th or something, and it wouldn't become something squared. So the only way to make this quadratic is if these exponents, if you could take the second one and multiply it by 2 to get the first one. 2 times 2 doesn't make 8. So it's not possible. This one doesn't work. No, it's not possible. And you can write that down if they ask you. It's not possible because if I make this a u or something, this would have to be u to the 4th, which doesn't make it quadratic. It keeps it fourth degree. So can we do the same thing with like a radical? This one, d. Well, if I was going to have a u substitution, what should I make u equal? Remember, you look at that second term. So can I make u equal to x to the 1/2 power? Well, that would make this minus 9u plus 8. Does that make this first term u squared? Well, let's see. If I have u squared, that would be x to the 1/2 all squared. Does that equal x? What do you do when you take a power and you raise it to a power? What do you do with those exponents? Multiply them together. Does 1/2 times 2 equal 1? It does. And the other way to think about this is remember that x to the 1/2 means the square root of x. And the square root of x all squared does equal x, right? Because the squaring undoes the square root. They undo each other. They're opposites. So this would work if you made u equal x to the 1/2. So that's for quadratic expressions. Now we're going to get into the equation piece where it'll connect more because we're actually going to solve for x, which is the grand reason why we do all this. It may look confusing right now until we actually get going. Any questions about A, B, C, or D? Okay. Example 2. I have to solve this equation. It is currently in 4th degree. And can I make it so that it's quadratic? The answer is yes, I can. What should I let u equal? Yes. So you can make a little note. Always write the note down of what u equals. Let u equal x squared. And then I will rewrite this with a u. U squared minus 13u plus 36 equals 0. How would I solve this quadratic? What's the fastest way to do it that I always check? Greatest common factor, that's the first step. That doesn't work. Is this a difference of squares? No, it's not. It's a trinomial. Can you factor this trinomial? Can I come up with two numbers that multiply to 36 that add to negative 13? I can. Can you? Get it? You. I know. I'm so good. Anyone? No? There are 32 people? Okay, wait. Negative 9 and negative 4. Okay, now, can we get the u alone? Can we solve for u? We can, right? What do we use? What's that property called? Do you remember the vocabulary? Katie. Yay! Zero product property means you set each one equal to 0 and you solve. So u equals 4 and u equals 9. Now here's the most important concept of the entire day, this next sentence. We don't care about u. No offense. What do we care about? X. So what do? Well, you let u equal x squared, so you got to plug it back in. X squared equals 9. X squared equals 4. How many solutions do I expect to get here? No.
4.
What's the degree? 4. I expect to get 4. Hopefully I get 4. Well, here I could take the square root of both sides. This becomes x equals plus or minus 3. And then here I can solve for x2, and x equals plus or minus 2. There are a lot of answers. 4 of them, to be exact. You should start making the link between seeing a degree 4 and expecting a maximum of 4 real zeros. And remember that we don't care about it. Okay, ready for another? Okay. Now, not all of these are necessarily u substitution ones. This one's not a u substitution problem. Why? Well, because it's an odd degree for one. But can you use your skills, your facts about cubics or quadratics and factoring to come up with a way to solve this? Let's see, is there a GCF? No. Is there a difference of squares? No, it's not a difference. It's a sum. It's a sum of what? Cubes. So what's the cube root of 343? It is a number. 7 is the number. So do you remember how to factor that? If not, find your factoring notes that has it on it. The sum of cubes. And I will confess that I had to look it up this morning, so enter it in your smartphone or something and figure it out. Okay, now this seems to happen every year. Some students look at this kind of a problem and they say, well, why couldn't I just subtract the 343 from both sides and then just take the cube root? They are the thinkers. They be thinking, except they be thinking somewhat incorrectly. Why? Because if you do that and you end up taking the cube root of negative 343, you only get one of the 3 answers. Your answer will be negative 7, which is an answer, right? But there are more answers contained within this trinomial. So try to factor. Factoring is the best way to go. What else can you do if you're not really sure here? You could graph it on the graphing calculator or your wonderful fruit app. That's way better. And figure out where the zeros are approximately. But remember, your calculator will not give you an exact answer, like in radical form, and your brain here will if you work it out with factoring. So now we use the zero product property. So we set each one of these equal to 0. And then also this lovely thing. So what's the solution we get on the left? Hey, that yields negative 7. On the right, we come up with 2 numbers that multiply to 49 that add to negative 7. 7 and 7 don't add to negative 7. 13 and 3 don't multiply to 49. Maybe $10 to figure it out. Why would I say something like that? Because I know with mathematical certainty that it's not possible. That's why, of course. I'd never give you anything. We can't factor it, but can we still solve it? Complete the square or there's nothing to slide. The 1. Slide the 1. Quadratic formula. Let's do that. I like that. Plus then I get to sing the song and I need an excuse to sing. Okay. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I get to show you some quadratic formula shortcuts. Because, you know, it's like every other teacher. Make you do the hard part first, then we show you the shortcuts. It's not a waste of time. It's a learning experience. It's so you can retrace the steps of your ancestors. To make you feel more confident about life. So, what's negative b going to be? Negative b is going to be 7. Okay, how about b squared? 49 minus 4 times 1 times 49 all over 2a. Okay, here's the little shortcut that I'm about to show you. You could actually work all this out and multiply all these together, you know, like 4 times 49 and figure out what the solution is. Or you could just say, well, what's 49? That's like 1 times 49. Minus 4 times 49. What's 1 minus 4? Negative 3. So that would be like negative 3 root 49. Because this is like a 1 times 49. This is a negative 4 times 49. 1 minus 4 is negative 3. And then you put the 49 back in. See what I did there? 49 you can rewrite as 1 times 49. And then you have 4 times 49. These are like apples and apples here. What's 1 apple minus 4 apples? Negative 3 apples. I didn't even have to figure out what 4 times 49 is. Okay. Also, I'm not going to do 3 times 49. Because what? What's unique about 49? It's a perfect square. So that means here that I can have 7 plus or minus. So what's the square root of 49? 7. 7 radical negative 3. 7i radical 3. All over 2. See, mathematicians are just smart, lazy people. They really figure out how to do things the fastest way because they're lazy, but they get really smart about it. That's why they invented the calculator, yes. But they also had to program them. Good luck with that. So how many solutions should we expect? If we go back up to the top here, what was this thing originally? Cubic. Did I come up with 3 solutions? I did. Here's 1 solution. Here are 2 more. 3 solutions, 3 real solutions. Actually, 1 real solution and 2 complex solutions. There's 9. It's complex. So if you were to take the function y equals x cubed plus 343 and enter it on your graphing calculator, you will only find one place where it crosses the x-axis. But there are in fact 3. 2 of them are lurking on the imaginary plane. Wow. Questions about B? Example 5 or whatever this is. Don't remember. Example 3. No, we got it? Easy peasy. Okay, example 4 then. I think there are 5 examples and then a whole bunch of you tries. So Don't get discouraged. You'll get to try it. Yes, of course. This is a U substitution problem. What should U equal? You mean x to the 1/3? So then you have to check to make sure, does U squared equal x to the 2/3? So if I have U squared, that would equal x to the 1/3 squared. Well, what do you do with those exponents when you have a power raised to a power? You multiply them together, and then 1/3 times 2 equals 2/3, so it checks, right? So I can make this U squared minus 6U plus 5 equals 0. I kind of call these textbook problems because they're not very prevalent in the real world. But that's okay. They're still fun. How do you factor this? Is it factorable? U minus 1 times U minus 5. Are we thinking 3 and 2? 3 and 2. Make it 125. And then I can use my zero product property. So U equals 1 and U equals 5. And now I'm done. What's that? No. Not really. This will be interesting to see what this is going to happen. So I'm finished? I'm not finished. I don't care about you. I'm going to try to come up with as many possibilities and ways of saying that today as possible. And x to the 1/3 equals 5. So how do I get the epsilon? Well, since it's being cube rooted, I would just cube everything. And 1 cubed is still 1. Don't write 3. 1 times 1 is 1. 1. It is not. You're right. And how about x to the 1/3? If I cube that, I end up with 125. And then I should probably check both of those answers, make sure that they work. If I substitute them both in here, 1 minus 6 plus 5. The 1 checks. 125 times 2/3 is 25 minus 6. And then that one checks too. 125 to the 2/3 is just 25. You just take the cube root of it and you square it. 5 squared, 25. What's the cube root of 125? 5. 25 minus 30. 6 and 5 is 30. 25 minus 30 is negative 5 plus 5. It works. You could also check your calculator. That's what you might want to do. But they both check. Standard. There are only 2 solutions to that one. 2 real solutions that we know of. Right now we don't yet have the tools to figure out whether there are more, and we don't have the tools to figure out how to find those. But we will very soon. Yeah. You will, because I already know. And there are a few things more enjoyable than imparting my knowledge to you. Okay, last one. For us to do anyway, at the moment. This is example 5. How would I do this problem? Well, before I do anything else, what do I need to create? No, I mean, yes, but I need to have a 0 first. So let's subtract 7 from both sides. And now I'm going to do what Dominique suggested, which is make a u. And Dominique, what should u equal? Radical x. Does that make x squared does that make u squared equal to x? Yes, it does. The square root of x times the square root of x is x. The square root of x squared is x. So the square root of x times the square root of x equals x, because this is the square root of x all squared, which is x. What's confusing about that? It's not confusing. This is x to the 1/2, right? Squared is x. It works. Are you drowning in the seas of despair? Okay, well, find a lifeboat. Okay, u squared minus 6u minus 7. What is that up there? Chapter 6 is what's up there. And a little bit of chapter 5. Would you like me to explain that to you in more depth? I will do it. I'm not afraid. Okay, so, Alexis, if u equals radical x, what does u squared equal? U squared means u times u, right? Well, u is radical x. Doesn't that mean radical x times radical x? How many pairs of x's are there? One pair of x's, so for each pair you pull one out and you get x. Like 15 different ways to come up with x. Okay. It wasn't weird. Okay, now can you factor this? How could you factor it if you could? Katie. Does that work? It works. So what does that make u equal? Zero product property. Oh, that's what u equals. But we don't care about u. So plug it back in. Square root of x equals 7. Square root of x equals -1. How many answers should I expect? Can we come up with that? Not sure. You're feeling 49, okay. And what else? 1. Now, why do I go back and check these answers all the time? Well, no, because there are radicals in there, and the radicals will always produce these extraneous solutions. So I have to check to make sure it works. So when I plug in 49, what's the square root of 49? 7. So what's 6 times 7? 42. Does 49 minus 42 minus 7 equal 0? Yes, it does. Okay. Now let's try the 1. What's the square root of 1? 1. So does 1 minus 6 minus 7 equal 0? No. So this one does not work. It is an extraneous solution. So in fact, there is only one solution to this one. X equals 49. Beware of the extraneous solution. Any questions on example, whatever this is, 5? No? Okay. Here's, you try 2. I don't know why I started with 2. I just skipped 1. I don't remember going through 1.